we have just seen that nitriles are electrophilic at carbon of the CN unit, and that's because of inductive withdrawal and because of resonance. If carbon of nitriles is electrophilic, therefore nitriles are susceptible to nucleophilic attack at that carbon. So this is the electrophilic site in nitriles, therefore nucleophiles can actually attack this carbon. But because of the fact that there is a multiple bond between carbon and nitrogen, therefore the nucleophilic attack type more specifically is of nucleophilic addition type. So therefore nitriles undergo nucleophilic addition reactions if they get attacked obviously by nucleophiles. So if we write a general structure of a nucleophile, something like that, so the nucleophile attacks the electrophilic carbon of the CN group, and of course one of the pi bonds is broken as a result. So this is the intermediate that's obtained. The nucleophilic addition intermediate. So this reaction is typically nucleophilic addition. This is actually very similar to the reaction of aldehydes and ketones with the nucleophiles at carbon of the carbonyl group. The only difference here is that there is nitrogen in the case of nitriles, whereas there is oxygen in the case of aldehydes and ketones. And remember that oxygen is more electronegative than nitrogen. The point here is nitriles undergo nucleophilic addition type reactions if they get attacked by nucleophiles. So this is therefore nucleophilic addition reaction. This is the nucleophilic addition reaction. Now, how can this be used in organic synthesis, or in other words, what are the applications of this nucleophilic addition reaction of nitriles? So this is again the general structure for nitriles. Nitriles get attacked by nucleophiles such as Grignard reagents. So Grignards attack this electrophilic carbon or the electrophilic site in nitriles to actually give, and interestingly, ketones. And again, that's a very, very useful reaction. So if you react a nitrile with a Grignard reagent of this general structure, a Grignard, okay, in a first step, obviously, followed by protonation of resultant intermediates, okay, the product will be a ketone. A ketone, obviously, that R is that one, okay, that carbon is that one, and R prime comes from the Grignard reagent, and oxygen obviously comes from the subsequent reaction with the hydronium ion in step number 2. So this is a very useful reaction because we can transform a nitrile into a ketone. Nitriles can also undergo hydrolysis reactions under either acidic conditions or basic conditions, and if they do, they give the corresponding carboxylic acids. So nitriles can be converted also into carboxylic acids of this general structure. So a nitrile is converted into carboxylic acids under either acidic hydrolysis or basic hydrolysis. So you can use an acid with heat. So this is acidic hydrolysis conditions, or you can use a two-step basic hydrolysis reaction if you react the nitrile with a base such as sodium hydroxide, and in step number 2 you involve an acid. So this is basic type hydrolysis of nitriles. Nitriles can be converted into the corresponding carboxylic acids with the same number of carbons, obviously, by either acidic hydrolysis or basic hydrolysis. So these are hydrolysis reactions for the conversion of nitriles into carboxylic acids. Nitriles can also undergo reduction with hydride ions. Okay, if nitriles react with a strong reducing agent such as lithium aluminum hydride, the nitrile gets reduced to the corresponding primary amine. That's also a nucleophilic addition type. Obviously, the nucleophile is actually the hydride ion in that case. Obviously, in this case, the nucleophile is the Grignard. So nitriles can undergo reactions with hydride ions, such as those from lithium aluminum hydride, a strong reducing agent, which gives the hydride ion as the active nucleophilic species, which acts as a nucleophile, in this case to do the nucleophilic addition on nitrile. So what's obtained actually is the corresponding primary amine, or CH2 NH2. That's a primary amine, and of course this should be, and it is, a very, very useful reaction, because you get now a primary amine, and of course the chemistry of amines is so versatile and rich. Obviously this conversion is of prime importance, because now you convert nitriles into carboxylic acid. So very interesting reactions, very interesting chemistry of nitriles. That's due to the electrophilicity of that carbon, due to inductive effect and resonance effect as well, and subsequent nucleophilic addition reactions of nitriles by nucleophiles.